Welcome to Processverse, where the impossible takes shape. Inside these walls, secrecy and engineering become one.
The B-2 Spirit is not built like conventional aircraft. Its structure begins with advanced composite materials shaped for invisibility.
Every curve of the B-2's flying wing is calculated, not for speed, but for silence on radar.
The B-2's engines are hidden deep within the wing frill, designed to reduce heat and radar detection.
The Spirit's stealth is completed not by shape alone, but by layers engineered to absorb radar. Before flight, the Spirit is tested, measured, and verified, not for appearance, but for invisibility. When it leaves the hangar, it does not announce itself. It simply exists.
This is Processverse. Real machines. Real engineering. No fiction.
Part number C129, grade aerospace. Verified. Looks good, no warping. This one is reading at 2.5 millimeters. It should go with the medium grade carbon.
Agreed. We need to keep the ram sheets separate on the lower rack.
Check the revision date on the alloy specs.
Revision 12 matches the manifest. Look at the luminescence on this edge. That indicates a slight imperfection in the resin.
Yes, I see the deviation. I'll make a note.
Is this the fuselage section 3? Oh.
No, place that on the wing stack over there.
Check the alignment on the leading edge.
Looks good here. The gap is within tolerance.
Okay, let's secure the edges.
Check the alignment guide on station 3. Looks good, calibration is set.
We need more clamps over here.
We need to verify these alignment guides against the layup schedule.
The tolerances here seem off by a few millimeters on this.
Check the fiber direction here. It has to follow the curve exactly.
Yes, I'm rolling it slowly to get the air out.
Calibration looks good on this segment.
Agreed. The laser alignment is perfect.
How is the orientation holding up?
Cross-check the fiber grain. It's perfectly aligned.
We are approaching the target pressure, but the temperature curve is lagging.
Adjusting the steam input now.
Watch the leading edge as we set it down.
All right, let's get the gauges on the curvature now.
Surface finish looks excellent.
There's a slight imperfection near this edge.
Okay, I'll note the coordinates and check the thickness.
Check the readout at station 5. We're still off by 2 millimeters.
Okay, applying tension now. Is the laser aligned?
Almost there. A little more on the forward clamp.
Check the alignment on this bulkhead. Looks good. Secure the clamps. Bring in the next support beam.
The laser guide shows a deviation of 0.05 millimeters at station 3.
That's within tolerance, but let's double check the caliper reading here.
I'm seeing a slight gap near the joint.
Mark it for adjustment, and we'll use the precise tool.
Ensure the alignment is precise before you clamp that section.
Got it. Verifying now.
Hold position while we adjust the cradle.
Roger. Stabilized.
Confirmed. Proceeding to staging area 33.
Tolerance on blade 17 is slightly high.
Noted. Check the housing clearance next.
Torque is set on volt 12.
Confirmed. Alignment is holding steady.
We are clear for the next phase.
Harness 3 secured, moving to the next sequence.
Confirmed. Power levels are nominal across the board.
Check the clearance on the starboard side. The laser guide shows a slight variance.
Confirmed. Adjusting the caliper now.
Strap secured on inlet 3. Verified. Looks good from here. Clearance verified on section 4.
We need to check the harness on connector B12.
Torque is set and locked.
The schematic shows this harness going into channel 4.
Okay, I'll reroute it now.
The readings here indicate a minor deviation. Can you micro-adjust the infrared sensor?
Roger that. Making the adjustment now.
Verify the pressure lines and the routing path here.
Path is clear, pressure is steady.
The reading on the J12 harness is stable 0.2.
Okay, I've logged it. Let's check the secondary ground next.
Alignment on the x-axis is off by 2 millimeters.
The schematic confirms that tolerance. We need to adjust mount 3.
Applying torque now. Check the readout. Did you connect the J22 harness yet?
Almost done. Just securing the last wire tie.
We need the calibration sequence started in the next 5 minutes.
The pressure differential is stable now. Look at screen 3.
Yes, that matches the expected output from the flight computer.
Make sure the edges align perfectly here.
Got it. Rolling it smooth now.
Check this spot, it's reading high.
Okay, I'll apply pressure here to even it out.
Much better, right within tolerance now.
Keep the pressure steady with the roller right along the seam. Like this.
Yes, that feels secure.
Temperature delta is stable at 25 degrees Celsius.
Check this seam right here, uneven coverage.
Got it. Marking it now for the night shift team.
Align this section precisely.
Rolling it now. Ensure the seam is tight.
Looks good. Proceed to the next panel. Check the thickness measurement here. It should be 40 millimeters.
Confirmed. The location mapping matches the schematic perfectly.
All right, bring the starboard section 20 degrees left.
Copy that. Moving 20 left. Watch the clearance on the scaffolding.
Alignment looks good on the left side.
Confirmed. We have clearance for the clamps.
Engage the hydraulics.
The leading edge is off by 2 millimeters at station 5.
Roger that. Adjusting the trailing fixture now. Make sure the bond is flush right here.
Okay, I'm clamping it now. We should be aligned.
Make sure the harness is secured at station 5.
Verified. The torque is within limits.
Check the alignment on section 4. It looks slightly off nominal.
Confirmed. The gap here is inconsistent with the blueprint specifications.
Okay, the clamp is free. Bring the jig out slowly. We have clearance. Clear on this side. All right, easy now. Slow and steady.
Aileron movement is within tolerance.
Confirmed. Run the diagnostic again on the starboard side.
The navigation systems are showing full integration.
Check the voltage on the auxiliary harness, make sure it's stable.
Reading stable at 5 volts.
We are still heavy on the left wing. Copy that.
I'm showing a 0.05 degree differential. We need 20 pounds to the right side.
Roger.
Look at this spot right here. See the inconsistency?
Yes, I see it. I will mark it now.
Idle thrust achieved. Parameters stabilizing.
Vibration check on the starboard engine is clear.
Verifying angle on the starboard wing, reading 0.015 degrees.
Cross-checked. The inclinometer confirms the reading. Adjusting the jig now.
That's the last certification logger on the tablet.
Great work. The aircraft is fully tested and ready for airworthiness approval.
Incredible.
Absolutely stunning. All that work paid off.
The uniformity of the ram coating is exceptional.
Look at the tolerance on that panel seam. It's flawless.
The alignment on this panel seems marginal.
I agree, but the ram coating is secure. Let's tag it for review.
Hold position at the yellow line, check all points. Port side clear, starboard clear. Rolling steady.
Hold it right there. A few more feet to the left, easy now.
Make sure you get the detail on the leading edge.
Okay.
Got it. The stealth coating looks perfect in this light.